Okay, let's go to module 4. In module 4, we're going to continue what we talked about. In module 3, we talked about mean, median, and mode. And there was a difference between the regular mean and the weighted mean. Okay, so we looked at those differences as well. In module 4, we're going to talk about measures of dispersion. What are measures of dispersion? It is one of the measures of dispersion is range, which is basically the simplest measure of dispersion. So when I have some numbers, I want to find the range of those numbers, which is very simple, right? I mean, let's say I eat out the following number of times each month for the last months. So I ate, 5 months back, I ate only 7 times. Last month, I ate 4 times. In between, I was eating a little more. Okay, so what is the range of the sample? The range of the sample basically is the highest number, which is this, and the lowest number, which is this. If I subtract the highest number from the lowest number, then if they subtract the highest number to the lowest number, then I get 7 times. Okay, so basically if I take 11 minus 4, that is 7 times, and that is going to be my range. So my range in the last 5 months of eating out is 7 times. Okay, so that's how I find the range. So this is a very simple measurement that I can do. Now let's go to the most important one in the measure of dispersion. Variance is actually the most important measure in statistics. For instance, I have, this is 0. And this is, let's say, 1, 2, 3, 4, 5 observations. And I have, my observations are 10 seconds, 15 seconds, 30 seconds. And then maybe minus 10 seconds, minus 15 seconds, and minus 20 seconds, or whatever, whichever way I want to do. So now, if I have a curve which is basically going from, something like this. So my first observation, this point, my second observation is this point, my third observation is this point, fourth is this point, and the fifth is basically this point. Okay? I can find out how these points are behaving in terms of what I have. And let's say this is the mean, or the X bar, which is population and sample. This is the mean. And if this is the mean, I can say how much these points are varying from my mean, how much it is away from my mean. That is called the variance. This is of so important to me, simply because if I want to be around the mean, let's say, hey, I'm taking 15 seconds one day, I'm taking 0 seconds one day, another day I'm taking minus 15 seconds. What is this? I want to make sure that I'm in this range. I want to be in this range because this gives me the accuracy. Okay, in measurements. Then I can say that I am varying this by 15 seconds. I'm varying this by third observation by minus 15 seconds, so on and so forth. I can do that, right? So that is the variance. So I can see that how far I am. And if I really want to bring it to here, then I need to strive to bring this point to here. Strive this point to bring it here. Strive this point to bring it here, so that I can be within the tolerance. So for instance, I'm making different wood pieces of the same length, and I'm cutting it same length. Okay, so my first wood piece is off by about 15 millimeters. My second wood piece that I cut was perfect. My third wood piece was off by, shorter by 15. This was longer and this was shorter. So this was longer and this was shorter. My fourth one was shorter. My fifth one was also shorter. Okay? But I really want everything to be here in this line, like my second piece. How do I do that? So I know now I am off by these number of points, right? That is what variance will do to help you to find out how much you're off and how much you need to bring it back so that you can be within what you want. Okay, that is the variance. So this is a great thing in statistics. When you take measurements, how you want to be within a process. And the process here for me is this point. That is, I want to be within 1 or 2 from my 0 point. That is my process. Everything else is off except the second point, which is within my process. My fifth point is within my process. Every 1, 3, and 4 observations are away from this process, right? And that is the idea of variance. Now let's go ahead and look at how to calculate these variance. Okay? Again, calculating variance basically is you can calculate the sample variance, and of course you can calculate the population variance. The sample variance basically is denoted as S is the sample variance. Okay, S is the sample variance. So let's looking at it. S is the sample variance, and the same thing that we are doing. Here, what we are doing for the variance is that if I have this mean, I'm going to calculate the difference. If I have this point and I have this point, I'm going to find the distance between the mean and these points 1 and 2. And then I'm going to add those points and then divide it by the number of points is 2 here, 2 minus 1. So the number of data values here, n, is 2 in this case. The x minus x, the distance between this point and here is, let's say, 1. The distance between this point and here is, let's say, minus 1. So I can find, using this formula, what is my actual mean. So let's go ahead and do it. Now, let's take an example of, so I order pizza to my house, okay? And the delivery times of the pizza is given. The X bar, which is my mean, is 7.8, which means I expect the pizza man to deliver in 7.8 minutes. That's all I want. I want this every time I want this band to deliver, it has to be 7.8. So that is my expected, so that is going to be my average or the mean. Okay, so this X bar here, I'm set now as 7.8. Okay, this X bar, I'm set as 1.8. So I'm going to make a table. So first time the pizza guy comes, I measure the time and I'm getting 7 minutes. Second time he makes it to my house in 9 minutes. Fourth time he makes it in 11 minutes. The fifth time, boy, this was very quick. This was very quick. So actually he made the pizza to my place in 4 minutes. So how do I work on this? I have to use this formula. How do I use this formula? So first thing I'm going to do is I'm going to take xi minus x. So which means for each xi, which is 7 and 7.8, this is my 0.8. 7 minus 7.8 is what I'm calculating. 9 minus 7.8, 1.2. 8 minus 7.8, 0.2. So on and so forth. Okay. Now I'm going to 2 to the power of 2. Squared. So minus 0.8 squared is 0.64. 1.2 squared is 1.44. 0.2 squared is 0.04. 3.2 squared is 10.24. Minus 3.80 squared is 14.44. The total is 26.8, and this is my value. 26.8. How many times the guy has delivered pizza? 5 times. So n is equal to 5. So 5 minus 1 is 4. So 26.8 divided by 4 is 6.7 minutes. And this is my variance. Got it? So it's actually very simple finding the variance. So all you do in this case is, if I give you the mean, the mean is 7.8. And I give you these data. Then you create a table like this, and then you find out xi minus x bar squared for each one of the values. You total them, and then you take the total divided by the n, which is the number of times, minus 1. That gives you the sample variance. So this is how you find the sample variance. Okay, so when I give you some data like this, usually it is the sample variance. Okay, let's do one more thing. Now, the variance of a population. If I take the whole population, the pizza example, what I did was only for 5 days, but I have ordered pizza 300 times. The 300 times is the population, and the 5 times is just the sample. Okay? So I can calculate, I can observe for 300 times and then find the average, the mean, and then I can find the variance. Or I can take just the sample, which is just the 5 days. I can find the mean, and then I can find the variance. It'll be different. The variance of the population is going to be different than the variation of the sample. But for me, the variation of the sample is good enough. So that's the reason I'm taking those 5 times and doing it. Most of the time, you take a sample variance. Most of the time. You don't do the population that much, because it is very tough to do observations on an entire population. So you take a sample and do it. That's a basic idea. The one thing that you want to know is, in a population, the only difference is this one here, this guy here. The number of data values. You're not taking it as n minus 1 in the sample variance, whereas in the population variance, you're going to just take the capital N, which is just the number of data. And of course, mu is the population mean. And instead of S, we are using a Greek letter called sigma. Greek letter called sigma. Okay, so that's how you calculate the population. The next thing is basically the second most important, or sometimes even more important than the variance, is standard deviation. So standard deviation is actually equal to the square root of the variance. Okay, square root of the variance. So note that when we talked about the variance, we actually talked about S squared. And when we talked about the population variance, we called it sigma squared. Okay, so the idea is this: the sigma squared or the S squared is the notation that we are using. Okay, now the standard deviation, we are going to just use this S squared or sigma squared as the variance, and that's why it is a square root of the variance. Okay, so the square root of the variance is pretty much what we are talking about as the standard deviation. Okay.